Okay, so it's my pleasure to introduce our first virtual seminar speaker for the ESS Department Seminar, Professor Kim Cobb. So Kim did her BA at Yale in 1996 and then completed a PhD in oceanography from the Scripps Institute of Oceanography at UC San Diego. She is currently the a professor of Earth and Atmospheric Sciences at Georgia Tech. She holds several other positions at Georgia Tech, including the Georgia Power Chair, which is an awesome title. The Georgia Power Chair, and she's the director of the Global Change Program, which maybe she'll talk about a little bit today. She's also the Advanced Professor for Institutional Diversity and the director and founder of the Carbon Reduction Challenge at Georgia Tech. She is extremely accomplished and has many awards under her belt. Most recently, she was awarded the 2020 Hans Oeschger Medal from the European Geophysical Union for her paleoclimate research, which focuses on using corals and stalagmites to reconstruct tropical Pacific climate over the last decades to millennia. Today, she's going to talk to us about some more recent work she's been doing on climate resilience for the 21st century, smart sea level sensors. So I'll turn it over to you, Kim.
Okay, great. Well, thanks so much for inviting me, Kathleen, and company. And it is a great honor to present to you guys remotely today and to give us all, I hope, a much needed distraction from some of the headlines and our daily grinds. I know I am homeschooling 4 kids these days and trying to keep my head afloat and stay sane. And so I'm really happy to share with the earth science community today and remind ourselves that we work together and we have so much to gain when we share like this and kind of keep our heads above some of the fray as we can. So what a great time to celebrate some science. I'm going to talk about some very new work that we're doing at Georgia Tech here. And with that in mind, let me just share this. I think this will work. Well, you guys see that okay? Yes, okay, I see some nods. That's good. Okay, so really what I want to talk about today, if anybody kind of saw the abstract, you'll see a little bit where I'm going, but this is a project that I'm leading down on the Georgia coast, which is focused on the perennial problem of coastal flooding around our very low-lying coastal region. And so this is work that is highly collaborative, and it's basically just getting started. It's one of these mega projects that hopefully will really deliver deliverables after deliverables and benefits for the community. But I'm going to show you where we are and a little bit about where we're going in the future. And so those of you who know my work, and of course Kathleen just cited some of the work that we've been doing for over 20 years now, focusing on extracting climate extremes from the past, using coral records from the middle of the Pacific Ocean, as well as cave records from Borneo. And this is just one of our lab's latest publications, just out of GRL, documenting some evidence from those very records for enhanced El Niño activity in the last 50 years relative to the pre-industrial. So certainly not the first to say something like that. Won't be the last, and there's a lot of counterpoints out there in literature, so let the battle rage on that point, but certainly has really allowed me to see how we can leverage past climate information to help understand future climate trends and extremes in areas that for which we have just very little instrumental climate data available. So this is work that is very field intensive. So over many decades, I've been privileged and extremely fortunate. Some of my most impactful moments of my entire life have come from the field. This is a photo of me installing a temperature sensor on a very remote reef, Christmas Island in this case, which is our primary research site these days. And this is 2014, and here you can see the kind of reefs that I'm used to diving on. Very remote, very pristine, very high coral cover, high coral diversity. These reefs are some of the most incredible reefs in the world for their remoteness, in fact. Of course, 2014 was just the beginning of what was to become a massive El Niño event that hit our research sites like a freight train, unfortunately, through most of 2015 and most of 2016, characterized by ocean temperatures that exceeding the threshold for coral bleaching. And so, you jump in the water on one of our expeditions, and the water temperatures of 31 degrees Celsius along the equator in the Central Pacific, which is about 3 degrees Celsius above normal for that site. And so this is a picture of the corals from April 2016, where you can see just wholesale death and destruction on this reef. Lost most of the reefs at this site. Up to 85% of the reefs were killed during this extended, protracted ocean warming event, associated in part with a massive record-breaking El Niño for this region, but also, of course, influenced by the steady creep of baseline ocean temperatures across the world associated with anthropogenic warming. And so, certainly after this event, my research program changed quite dramatically in that we were kind of looking at a coral archive in my lab that was all of a sudden completely irreplaceable. There will never be any colonies at this site that exceed a decade or two in duration, probably. The corals that I had lovingly patched up over my decades of coral reef conservation and lovingly restoring the heads that we had drilled were unfortunately killed during this event. And so those grandparents will never come back. And so we're really looking at a series of ecological collapses that are occurring in our very lifetime here, much sooner than I thought would happen, and much sooner than many coral reef experts had thought would happen. This doesn't signal the demise of global reefs by any means, but certainly a harbinger of things to come as coral bleaching creeps into our lives on a yearly basis. Of course, this last austral summer, hitting the Great Barrier Reef quite significantly, as some of you may have seen through the headlines. And so much closer to home, this is another problem with water, but here in this case of Georgia, an issue of coastal flooding that's associated with anthropogenic climate change in a very different way. And part of what happened to me after the 2016 bleaching event was a recognition that we are simply out of time, and it's far too late to sit back as a scientist and kind of throw my hands up to hope that whoever is the recipient of these scientific wonders that we have created as a community will act to act on that evidence and act on that data to create policies that will be sustaining to our planet, to our species, and to the life as we know it. And so part of what motivated this pivot to the work I'm going to talk to you about today is a desire to work in my own backyard in Georgia, where I can have immediate impact on the lives and hopefully livelihoods of my fellow Georgians, and that hopefully through that work, we can create stories that can be told that are based on real projects and real people and real changes that are happening on the ground to make Georgia a place where you can point to some climate leadership in a way that wasn't maybe possible before, or wouldn't rattle off your tongue, shall we say, Georgia climate leadership. Yeah. So this is a long game project, something that meets a current need, and is something that is unrolling today. And of course, in California, you have your own pressing local needs to address. And so thrilled to talk to faculty and students alike who were mentioning their seminal work on understanding biogeochemical cycles in arid regions, understanding impacts and propensities for wildfires, understanding drought dynamics, climate extremes, all of the work that goes on at your institution to enrich the landscape for evidence-based policymaking in California. So this is not unique to Georgia by any means. This is something that we're watching play out across the nation, and there is just a call coming out from communities that are more eager than ever to leverage science and service to their long-term health and prosperity. Of course, I say health and prosperity, I'm reminded of how critical a role science is playing right now in shaping the trajectories for health and prosperity across this nation by the evidence-based policymaking, or lack thereof, that is going on at the governor level. Okay, and so what I would like to talk about today is something that I've also been thinking a lot about, which is something that is labeled here the climate solutions paradox, but it really is recognizing that we've known for so many decades that humans are warming the planet, and we've known over this whole time frame what is required to begin to address this global scale problem. And we can argue whether that has happened or has not happened, but the other reality of the situation is that while we know so much about the causes and drivers of anthropogenic climate change, we actually know precious little about how to really equip communities to keep themselves safe from some of these coming threats. And part of that is because we're so late to the game, that we have so much catch up to play, that we haven't done the hard work of learning and creating knowledge and frameworks along the way as we should have been doing. We're playing a little bit of catch up here. And that's really what I'm going to talk about today. How do we play catch up on a problem like coastal flooding, something that we have had our heads in the sand for here in Georgia for a very long time. And so here's a class of things that we know pretty well. Well, we know well enough to know that water is rising across the globe. We know some of those rates, of course, historically, to levels of precision that are astounding with respect to the satellite retrievals going forward. The IPCC and the National Climate Assessment in particular here cites a 1 to 4 foot sea level rise by 2100 is likely. That's a 68%, and a 10 foot as possible, which is something that leaves a lot of jaws on the floor across coastal communities of Georgia, because that would mean that much of the county would be underwater by that time frame in 2100. So that's kind of the boundary conditions of what we know. And that is a lot. That's a lot to know that's going to happen. And there's no doubt that sea level is going to fall somewhere between, I would say probably 1 meter and probably 3 meters over the course of this century. My personal bet is still at 1 meter, but that has no bearing here. The science informs this distribution. However, what we don't know is something that is very disturbing to residents across low-lying coastal areas, and that is the fact that coastal flooding is no longer just a king tide event, which we read about in Miami every so often, these so-called sunny day tides, when you have a massive king tide and water starts seeping up through the sewer systems in Miami and flooding the resulting low-lying areas. This is a picture of my co-PI's home in Savannah that was flooded during Thanksgiving Day 2018, and he looked out his window and there's ocean water on his lawn. Okay, and so he's asking himself, what's going on and how long is this going to last? How bad is it going to get? And there's a blue sky overhead. And so what we don't know about this particular area is what are the key drivers for coastal ocean flooding? How accurately can we predict them? What kinds of observing systems do we need to help decision makers prepare for these events and keep people safe during these events? All of those questions are things we don't know about this particular flood vulnerable area. And so this is a basket of things that we don't know. And this question about the things we don't know is where we have the seeds of the project I'm going to talk about today. And so again, just looking at the time trajectories for global sea level rise, we have uncertainties related to where emissions trajectories are going to be. We have uncertainties with the response of the climate system to those emissions trajectories with respect to warming, and then with follow-on ice sheet losses. So all of that gets baked into this incredibly large band of uncertainty going forward. And so we know this stuff, but we also don't know how to create management frameworks and decision support for local officials that are trying to make good use of public dollars and keep people safe and keep their communities solvent and existing over these next decades and thriving. They don't know, they don't have the tools to support decision making under this kind of spread of uncertainty. And so, they can look at this graph till they're blue in the face. It's not going to tell them what to do. So how do we create a framework for enabling some of this decision support? Now, here in Georgia, we have one NOAA tide gauge for the entire 120 mile coastline. And so that tide gauge is in Savannah. It's at Fort Pulaski. And it has shown sea level rise since the 1930s, and the trend is very similar to the global average, about 3.2 millimeters per year. And you can see some very high spikes towards much higher values that are associated with either seasonal extremes for ocean circulation changes, or in some cases, individual days of storm surge that have piled up water on the coastline there. But this is the only tide gauge for the entire Georgia coast. And when you talk to people on the ground who are concerned about coastal flooding, when you're thinking about the complexity of the Georgia coastline, which is cut by any number of small and large rivers and estuarine systems, and you're talking about the dynamical landscape of having to face hurricanes, wind events, extreme rainfall over this last decade and in coming decades, this becomes a very, very dynamic and very complex natural system to try to understand. And we all can appreciate how one tide gauge is simply not going to provide enough information to characterize that environment very well. And so enter this project that is about almost 2 years old now. It's called Smart Sea Level Sensors. And it was a project that was formed from a conversation between myself, who's just an oceanographer after all, an observational oceanographer, and a colleague of mine in computer science named Russ Clark, who is a mobile apps and distributed sensor specialist. And he was the one who had his house flooded during Hurricane Matthew and Hurricane Irma. And then on Thanksgiving Day again in 2018, and got to thinking that they really needed some more measurement devices, and they needed a better prediction system for handling the flood risks on a short-term and long-term basis. And I was looking for a project that would ground me in my state on climate solutions. And I love the ocean, so I could pivot my skill sets and observational sensors and instrumentation to this specific system and build something up. And so this website, sealevelsensors.org, you can check it out. But we have 4 main goals. We're interested in delivering real-time data. We are interested in making hyper-local forecasts, so neighborhood-level forecasts on for as long a prediction lead as we can. In our case, we're targeting at least 3 days of accurate predictions. We're thinking about building a framework to support long-term decision-making around coastal resilience, and specifically flood risk mitigation. And then number 4, none of that is possible without raising the literacy around climate science, coastal flooding, sea level rise, and general community awareness and engagement with the science and the data around this problem as it's going to march forward. So the awareness and education piece is absolutely critical. I'll talk a little bit more about that. And so this project has become this mega project very, very quickly. I should mention that it started from day 0. Before we even started the project, we reached out to our counterparts in Savannah and the Chatham Emergency Management Agency. And so they are our co-PIs on this project from day 0. And so Nick Deffley from the City of Savannah Department of Sustainability and Randall Matthews from the Chatham Emergency Management Agency, we are the leadership team for the project. We do all the project management together, and we make all the decisions together collaboratively between the 4 of us. And so that's a city municipal authority, a county municipal authority, and 2 scientists at Georgia Tech from different colleges at Georgia Tech. And so what this ecosystem is trying to communicate is that there are a huge variety of different kinds of stakeholders that call themselves part of this project. The National Weather Service, Georgia Climate Project, which is a consortium of universities across the state focused on climate, the Tybee Island Marine Science Center, which sees 60,000 visitors a year, Sea Grant, Georgia. And I can go around this whole thing, but I won't in the interest of time. But I just want to point out one key partner here, which is the Harambe House on the bottom there, Citizens for Environmental Justice, which is a 30-year-old organization based in Savannah focused on advancing environmental justice for Savannah's underserved populations, and specifically low-income African Americans who have long been victims of structural racism and historic marginalization in Savannah and across the entire Southeast for that matter. And we are so thrilled and humbled to call them a project partner and to be working together to advance some common agendas that we have to hopefully shape the future of what climate resilience looks like from the lens of equity in these communities. And so I'll talk more about that in a minute. That's just a bookmark. And so this is the map of the current sensor array that we have on the ground. To our knowledge, it is the highest density sea level sensor network in the world, which is kind of ridiculous that it's based in Savannah, but there you have it. These are 43 sensors, and they cover a very small geographic area. And they have their highest density along the coastal areas where the ocean dynamics interface with the estuarine dynamics and the hydrological dynamics of the inland watersheds. And that's where the complexities really come to light in our data sets. These data sets have been going for a minimum of several months for the newest installations and a maximum of about 2 years since our first sensors went into the water. And here on the right, you can see what these sensors look like. So it's a box, it's a shoebox size. It's a waterproof housing on that sensor. And there's a little cone-shaped gray piece coming out of the bottom of the shoebox, which is an ultrasonic device pulsing down to the water surface. And that is a travel time calculation that tells us the distance of the line of sight there. And then the antenna here is relaying that data back to a gateway device, which is reporting the data back to a Georgia Tech server over the LoRaWAN wireless connectivity protocol. And so this is a gateway backbone that we've installed across the county. So we have 12 gateways across the county, and they are each looking at a radius of 1 to 4 miles of sensors. And the cool thing about this is that these gateway devices can actually service any number of different kinds of sensors, traffic sensors or air temperature sensors or air quality sensors or anything you want. They're really low data rates, and we don't have to pay any cellular data or wireless data because we provided the infrastructure ourselves. And so this is actually a enabling infrastructure for the city or the county to use going forward for any number of different applications. So that's a neat infrastructure component to this project. And so these gateways are about $1,500. They're very inexpensive. The sensors themselves are $250 of off-the-shelf parts, compared to tens of thousands of dollars for an individual NOAA tide gauge. That's why there's only one on the Georgia coast. And so the idea is that eventually we can build out an environmental sensor network. We're looking at temperature and air quality for this summer. One of the key questions, of course, for anybody who's involved in observational work is how precise and accurate are these Georgia Tech designed sensors? And we were fortunate last year to get access to co-install 2 of our Georgia Tech sensors with the NOAA tide gauge at Fort Pulaski. And so they sit about 1 meter apart from each other at the tide gauge site. And so they're looking at the same water levels through time. And it's hard to see on this plot, but there's a huge tidal range in Savannah, but the sensors are actually overlaying the NOAA tide gauge exactly in line with those data sets. And so much so that if you crank through what the residuals are on our sensors versus the NOAA tide gauge, you get an average of less than 1 inch of error between our sensors and the NOAA tide gauge. And at any maximum time is about 6 inches at a maximum offset. So that's probably even could be waves, different waves that are interfering with the sensor lines of sight slightly differently across 1 meter of ocean. But this is, I think, extremely encouraging data that helps us understand what the strengths of the network will be and helps decision makers understand, of course, how accurate these data sets are across the county. So these data sets are only part of the program, because to really provide the kind of operational utility that the stakeholders want, they really want to have some predictive capacity as well. And so it's very, very important to them to have access to real-time data, which is what the sensors are providing them through the portal that we have. But what they really want is as much lead time as possible to prepare communities for flood emergencies. They want to know how high the water is going to be and where the water is going to be. And that is a complex function of the wind directions and the wind speeds and any precipitation that is coming, and of course, the state of the tidal height and its dynamics across this terrain, which is actually quite complicated for those of you who know coastal oceanography. And so this is a model that we've developed. It's bespoke for the Savannah area, and you can see the model grid there on the left. It is running at a 10-meter resolution, and it snakes up into the smaller rivers and causeways across this area of Georgia. And it comes up into the Savannah River here, as you can see on the right-hand panel. And what we're doing right now is we already have a series of 3-day forecasts we are making in kind of research mode, and we're ground truthing those against the sensor data as they come off. The more extreme scenarios we can get, the better. So, you know, this hurricane season may provide some interesting and very important benchmarks for us as a team. But nonetheless, where we're going with this is to try to get really accurate forecasts for the regional area going forward. And so this is just the first step of many steps we'd like to take, because once we get this ocean model put in place and we have it running operationally with its stated uncertainties and limitations, what we need to do to get a full grasp of the flood risk is to incorporate a atmospheric model and a land hydrology model, because as we have all seen with the past hurricanes events, it's not just the storm surge, it's also the precipitation that comes as the pile-on of these extreme weather events that really can make the difference between an area that floods catastrophically and one that doesn't flood at all. And so this is an essential component when we start to talk about flood risk for coastal communities, but yet this is really something that's not operational in any way across the coastal US, and it's a tall order to do properly. And so again, we're focused on the ocean piece and going to be moving to this piece in the next year once we get this ocean piece down. And as you can see down here, the last step is to incorporate a full model of urban infrastructure into this framework. And so obviously this picture here in Savannah helps us understand that the Savannah River cuts right through Savannah. On one side, there are these marshes. On the other side of the river, there's the Savannah downtown area. And it has very steep topographical changes. It has historic areas. It has low-lying areas. It has green spaces. It has concrete jungles. It has pockets of very vulnerable communities, pockets of very wealthy communities. We really would like to understand how this natural environment is going to interface with this, with the scales of where people live and the structures that they depend on, the transportation network, the grid, the medical infrastructure. All of those things become layers that we can assess once we have the physical layers of flood risk under our hands. And so one of the things we are able to do with the model is look at hindcasts of past hurricanes with the model and compare to observations for right now to see how well our operational model is doing. And so the model is in pink here. This is running across, I believe, this is actually Matthew, Hurricane Matthew. And you can see here that the model is doing a pretty good job capturing the magnitude of flooding across that particular event. Of course, we didn't have sensors in the water at that time, so this is just Fort Pulaski provides the only benchmark. But when we have the full sensor network, we can actually compare across the full sensor network and get an idea of where we're doing well, where we're doing poorly, and how to represent that to stakeholders. And so this is all an exercise in transdisciplinary research. I had never heard of transdisciplinary research until last year. So, and I am, quite advanced in science here. And so transdisciplinary research is really when you put together scientists and researchers from many different disciplines, but not only that, that's interdisciplinary research, but transdisciplinary research means that you're actually also including researchers and input from different sectors, for example. And so you have the academic sector, but you also have the non-governmental sector, you have the governmental sector, you have the private sector. And so when you have these people defining the research trajectory and defining the deliverables and making decisions together, then you have a transdisciplinary research framework. And that is what we invented without knowing a name for it. That's basically what we did. And it's very messy, and we are learning as we go because none of us were trained in conducting transdisciplinary research. In fact, I didn't even know there was a term for it until I was doing it for a year. There's practically no funding out there for this. This is beginning to change at NSF, and props to them for defining some pockets that are targeted towards transdisciplinary research. But again, it's only 1 or 2 calls out of the entire NSF landscape. So let's hope that that continues to increase and accelerate going forward. And it's also, of course, one of the most promising avenues to find and implement real-world climate solutions for communities that are desperately in need. And so how do we bring information from the IPCC level, those trajectories of potential sea level rise scenarios with their probabilistic uncertainties attached, and how do we help stakeholders engage so that they are confident that they're making evidence-based decisions for their communities? That pipeline of value add is basically broken in many ways, or never existed. And so we really have to come in and build that connectivity as we go, and it doesn't happen overnight. So this is kind of my recipe for transdisciplinary research here. So, we ask what your problems are, then we listen to you when you talk about them, then we ask and we listen, and we ask and we listen, then we go do something to try to help maybe advance that knowledge or advance that solution set. And then we ask if we're doing it right, or if we could do it differently, or what worked and what didn't work. And we do all of this. And then when we mess up, we apologize, because there's a lot of messing up in this terrain. There's a lot of messing up to go around, and you have to be ready to own it, to learn, and to do better, because this is critical. And this is one place where I messed up, and I had to apologize, and I'm learning, and I remain learning here, ever learning, which is understanding who is not at the table of this very large table we've created for transdisciplinary research and coastal flooding in Savannah. And we started having all of these public facing events. We were inviting lots of different stakeholders. Tons of people were showing up at these events. People wanted to install sea level sensors on their dock. They wanted to teach about sea level sensors in their school curriculum. Different municipalities wanted to buy sensor networks for their communities. Everything seemed to be going great until we started asking ourselves, wait a second, same kind of people seem to be showing up at these events. The wealthier communities that want to buy the sensor networks, wealthy individuals who would like to monitor the flood levels in their second home down on the coast, ... And who wasn't at the table were any of the low-income, vulnerable, marginalized communities of Savannah, who make up a very large percentage of the population and are extremely at risk from flooding and any other number of climate-related environmental stressors. And so this is just reminding us of that in a way that I think drives the point home. This is a map of potential economic losses across the United States by 2100, where the red areas are indicating counties of up to 30% losses by 2100. And when you dig into this report, which I don't go into here, but I encourage you to read it from the Brookings Institution, you will see that all of this red swath is really indicating the largest percentage contributor to this is mortality losses from extreme heat. And so what this tells us and reminds us is that many of the most vulnerable Americans to climate change are located in the southeastern United States, and they tend to be low income, and they can be urban or rural, and they are very often communities of color. And so this is just driving this point home that we all know is true, that the most vulnerable communities are those frontline communities are already the historically marginalized and already under-resourced communities are all around this country, but especially in the Southeast, and Savannah is no different. And so when we started to think about how do we change this, we thought, well, we are going to reach out to the leading environmental justice organization in Savannah, the Harambe House, and we're going to invite a partnership with them. And so we're very, very fortunate to have a meeting with the director, Dr. Mildred McLean, who is an amazing matriarch in her community. She is without parallel. Oh my goodness, you should just Google Dr. Mildred McLean and you will see some of her speeches pop up, and you too can learn. At any rate, we got a meeting and we sat down and I began to explain our program on sea level sensors. We were thinking we could install some sensors in the neighborhood. We were thinking a lot of things about, you know, infographics we could create and all this stuff. And you know, she said she had some things to say. And so, and then we were quiet for about an hour and a half, and she talked for about an hour and a half, and she had a lot to say about the ways that her community had been used by researchers in the past, about the ways in which her community had suffered under poor air quality for decades, about the ways in which the EPA had turned a blind eye to her community's lead soil problems and contaminant issues, the ways in which her community had been sandwiched between a major highway and the industrial areas of the port of Savannah, which flank their boundaries on both sides. And she talked for an hour and a half, and then I had to apologize because I had come in with a very naive approach and with all the best intentions, but it had a lot to do in cementing this partnership. And so by apologizing and asking and listening and learning and with a whole lot of eating crow there and trying to do better, we have established a very long-term partnership with the Harambe House. And what we heard from them is that they want us to focus on their schools. What we heard from them is that they want us to focus on air quality, which is one of their most pressing and prolonged issues that has never been addressed sufficiently to their liking by the city, the county, or the federal government. And they also are interested in temperature as a variable that, of course, really impacts them during the hot Savannah summers and can cause very lasting health effects for their communities, including mortality across the most vulnerable members of their community. So this is the program that we started. So we are now expanding to air quality and temperature with this partnership using the same exact infrastructure that we've had online before. And so I don't want to belabor this pretty horrible graphic that I submitted a proposal last year. As proposal graphics go, it's pretty bad, but I want you to focus on the green triangle there, which indicates our focus on K through 12 schools as a nexus for community engagement and investment that has long-term benefits associated with it for everybody. And we are going to think about not just putting sensors in there, but building curriculum around these sensors. We're going to incorporate local knowledge from the students and the surrounding community into our research and to guide our research. And we're working with local HBCU Savannah State in getting some interns involved in the project from the higher ed side. And so I wanted to talk briefly about the map room, and I promise I'm almost done because I really want to get to your questions. But the map room is one of the enabling technologies that we're excited to develop as part of this partnership with the Harambe House. And the map room is something that is a digital display device, a data display device that enables a layer of interactivity to become part of the data as you go, as you conduct the session. And so here you can see this is developed by my colleague, Yanni Lukisas. He's in literature, media, and communications at Georgia Tech. And here you can see Dr. McLean and the Director of Sustainability in Savannah, Nick Deffley, working on this digital display, this projection of their city on this sheet of paper. And they're coloring in with markers things that might be community assets, things that might be community liabilities, transportation networks, things that make them happy, things that make them sad, where their kid went to school, where there's history for them, what stories they want to tell. They can stick Post-its on it. And it becomes this archive of an experience that people had together. And it becomes a way to embody the local knowledge that we need to have to successfully move forward in this transdisciplinary research and successfully work with and partner with these communities. So I'm very excited about the map room. It's a great device. Speaking briefly to our curriculum, I want to acknowledge the very amazing work of my colleagues, Jay McCoval and Tim Cohn. These are the K through 12 specialists at Georgia Tech who helped us create modules for a local high school in Savannah to assemble the sensors from scratch. And so last year with the engineering curriculum at Jenkins High School, and the teachers are, Grace and Tom are pictured there, their students assembled 30 sensors from start to finish and soldering and everything. They put their signatures inside the weatherproof box, and they stuck their Jenkins High School sticker on the side, and they were mounted on bridges across their community to be part of our network. And so the students love it, we love it, and the elected officials have been so grateful to everybody involved for involving the next generation in a skills building exercise that will provide dividends for the entire community for years to come. Likewise, my colleague, Professor Alex Robal, ice sheet glaciologist in my department, teamed up to create a sea level rise curriculum for the Savannah area schools that's available across the coast now on this website for middle school, which is where earth science is taught here in Georgia. And it just did an amazing job incorporating the sea level sensor data into that curriculum and kind of making it come alive for the students who, of course, are already experiencing sea level rise in their communities and will be grappling with this issue for decades to come. And so Kathleen talked briefly about the Global Change Program that I direct at Georgia Tech. And it's very exciting to talk about climate solutions these days and to think about what Georgia Tech could do to build research capacity around climate solutions in a way that I like the project I've just shared with you, but also to think about how we can equip the next generation to be the climate solvers that we need them to be. So they need a different kind of training than I got, than Kathleen got. We're going to need to help graduate students accelerate their progress towards being the change agents and climate solvers that we need them to be. And we also need to keep our eyes on the undergraduate populations to make sure that they're getting the foundational material, but also the inspiring stories and the opportunities to be change agents themselves as they make their way through our institutions. I know they're only there for a heartbeat, but we got to make it quick and we got to make it compelling, but it's what they want to, and it's the right thing to do. So how can we turn our institutions as quickly as we can towards the challenge of our time, both in the research and educational trajectories? And I'm not going to read these summary remarks other than to say that these kinds of low-cost distributed sensor networks are powerful tools for citizen science engagement, but also can drive amazing research agendas when we think about it right, and deliver incredible value for local stakeholders that are needing that kind of hyperlocal information and understanding to support their decisions. And then in general, there's this whole emerging area of transdisciplinary research, which is, I find, super exciting, even though I feel like a first-year graduate student again. But how do we turn that into really concrete experiences for our graduate students and undergraduates to get formal curriculum training, but also the real hands-on work that they're going to need to succeed in this business as the opportunities grow over the next couple decades. So with that, I will end it there, and hopefully I have lots of time for questions. Thank you. I know y'all are clapping. I can't hear any of it.
All right, so if anyone has a question, you can go ahead and unmute yourself. And oh wait, somebody's in the chat. Let's see. Oh, no questions there yet. So does anyone have a question for Kim? Oh, Claudia, why don't you go first? I see your hand up.
I was clapping.
Oh, sorry.
Thank you, Claudia.
Well, thank you for an amazing talk, Kim, which I feel like is a real call to action and really inspiring to hear. And I really appreciate you sharing your experience with the community. And I wonder if you have any general advice for scientists who want to, whether they're graduate students or faculty, who want to take first steps to do this type of community engaged research. What do you think would be the most important thing to think about from the beginning?
Well, you know, I mean, I didn't really think about this before I had this really pivotal conversation with my colleague. And so I think the most important thing to do is to find space and create spaces where you can talk about, you know, the dominant challenges that, you know, are in your backyards or of common mutual interest. And so there are enough challenges out there, God knows, but the key is to kind of think about creating environments for these cross-disciplinary interactions. And at Georgia Tech, it's not like we do that super great. We did have for that year a program called the Climate Fellows Program, which had 47 faculty from across the entire institution. And we got together every couple months and we did these kind of sound bites of our research. And started to talk about what kinds of things we might like to do together, you know, big buckets of regional problems that we might be able to move on if we could kind of bumble through a process together. So some of the work that I'm talking about today kind of was seated in that area a little bit, but that's you know, a happenstance. It would be great to kind of formalize something like that at an institutional level to provide those kind of spaces and common agendas that recognize the importance of identifying and tackling problems that are regionally grounded and must be informed in part by in-depth regional research.
Anyone else have a question for Kim?
You guys can also type it in the chat if you don't want to, like, you know, say something
Hi.
on Zoom.
Hi. So I have a question.
Yeah.
Did this project like create any sort of policy changes at the local government level?
I mean, it's very early. So one thing to stress about this project is, you know, these are very long games we're playing. This is not a quick payoff or a quick impact proposition. So yes, the sensors went in 1 year. We did have a very large number of public fora. We did meet with the congressman, we met with the mayor, we met with the county commissioner. We're meeting with people, and our message is very simple. Our message is, the ocean is rising. We're here to help. We have you have the highest density sea level sensor network in the world. We could be a big leader in this. It's not too late. I mean, this is simple stuff. And so ultimately it's a conversation starter, not a conversation ender. But we're not looking for quick wins, and they aren't looking for quick wins either. This is not an easy thing. Having said that, there was a massive changeover in administration in Savannah just this last election in November. And the new mayor is extremely invested in environmental justice around climate change in particular. And, you know, I don't think there's a direct link between our work and that election by any means, but there's a community appetite for this because of the recent flooding emergencies that they've had. And so I think it's too early to say that we can attribute, you know, something to our project, but we have made it very clear to everybody that we are there for at least a decade. And so their investments in our project will mirror our investments in the project, and we can all comfortably invest in these long vision that we need to have to build something great and something that works and something that's not a flash in the pan. This is hard stuff.
Now, Claudia?
Yeah, so thanks, Kim. I just wanted to let other people know I know Kim because she made me jump off a cliff once on skis. It was really great. It was way past my abilities, but we made it down the hill and it was really fun. So I had some question about what you've learned about sea level from this project so far. Is there certain areas that have surprised you, or how in sync is it with existing maps of flood risk in the area that you're working at?
Yeah, that's a great question. So I've learned all the stuff that we don't know, which turns out to be a lot, shockingly lot. And so our sensors tell us that the differential across even Hurricane Dorian, which was the most recent hurricane that our sensor network captured, was, you know, several feet across the domain of difference in flooding. And so, you know, that's just the difference between a whole neighborhood flooding and not flooding, for example, on that scale. And I also I did not appreciate that you didn't have to have a king tide to have this blue sky flooding in these flood vulnerable areas. I didn't appreciate that winds from the wrong direction at the right speed, you know, over the course of 6 hours could cause a flooding event in and of themselves at these sites. And I didn't appreciate how little warning anybody had about that, how nobody's watching that, nobody's tracking that, how there's no tool at NOAA, there's no data at NOAA, there's nothing at NOAA to help local communities prepare for something like that? So you start to see all the holes, and they actually start to look pretty big when you're on the ground talking to people about what they're living and what they're fearing. And it's a fear. It's a constant fear. It creates this sense that you're all alone, right? And NOAA only comes in when the storm surges are coming. Starting 36 hours out, they start providing your community with storm surge warnings and predictions and maps and things. And before that, you're just like, I don't know. And they don't handle compound rainfall. So in the back of your head, you're thinking, it's not just this storm surge. I have to add another foot because there could be extreme rainfall on top of this. So you start to feel the fear of local officials. You start to feel the fear of local residents. You start to feel the isolation that they feel, not having the support structures, not having the data streams, not having the predictive tools that they need. I wish we weren't here in this position, so far behind the curve when we've seen this coming for so long. But that's even more of a calling to people like me, who have known this is coming for 30 years, right? How can we watch communities just get run over by these freight trains, just like my coral reef got run over by this freight train? We have to do what we can to try to limit the damage.
Hey, Kim,
Any other questions? Oh, go
I
ahead.
just wanted to follow up about the transdisciplinary points, and I wondered if you had any ideas for how institutions or colleagues could help incentivize that kind of transdisciplinary work with stakeholders and communities and environmental justice that happens on a scale that's different from, say, an NSF-funded project.
Well, I wish it didn't happen. I wish there were NSF-funded projects that, pots of money that would really fund this work, because it is expensive. It's expensive to do it right, and you know this. But speaking institutional level, there are all kinds of internal seed grant opportunities, all kinds of discretionary resources that are mobilized towards institutional priorities every single year. And so it's just a matter of kind of thinking about how can we have some kind of laser focus on this type of work. And I should note, transdisciplinary research isn't something that just happens in service to climate solutions, right? I mean, not by any stretch of the imagination. You could have transdisciplinary research looking at Black feminist narrative development in the 1950s. I mean, honestly, you could do it on anything. Obviously, I think the universities, especially public-facing universities, I think feel a call to serve their communities along certain axes, and climate solutions is obviously an important one. So I think there's a program at Georgia Tech called Georgia Smart, which was where we got our tiny pot of seed funding to give life to this project. It was just 1 year, $25,000, by the way. And it was a project that forced you to partner as co-PIs with some municipal authority across the state. And so if you think about it that way, then, you start to have to put on your creative hat and you say, I've always maybe thought about this problem as something that could be, an important solution for a community, but I don't know where to start. Well, this is a way to start understanding what their needs are, what your skills and interests are, to build a common shared agenda, to allow stakeholder-driven research to be the research agenda, not to be the add-on or the afterthought, which is all too often what happens in an NSF grant, and the afterthought never comes to be. So that's what I would say. I'd say look at the Georgia Smart program not as the best example, because I don't think it's very robust enough. It's not big enough, but it's something that got us started, and forcing cross-sector, cross-disciplinary collaborations into a seed grant opportunity. If I ever am president of anything, that's what I would do, because people want to do this work. They really want to do this work, but they also want to do it under an institutional umbrella that has that support behind it.
Thank you.
All right, well, I think it's coming up on time here, so why don't we go ahead and end there. So if you want to unmute yourself and thank Kim again for a great talk. I'll clap anyway.
Thanks to you guys. And I want to say, if anybody has any questions that they weren't able to ask, just send me an email, kcobb@gautech.edu, and I'd be happy to shoot you an answer back if I can, or we can hop on a brief chat too. It's really been a pleasure talking with you guys today.